Okay, we're starting right now, so what we're going to do is start with the first presentation, and we're going to and the next this presentation is going to be about the difference between plasma devices and light emitting devices. So that we're going to try and make this distinction. The main reason is because many people got that confused. So hopefully this presentation is going to clarify that. And then we're going to make an ad hoc web page on this. So what is going to happen with each presentation, we're going to give the presentation, then we're going to get the your questions, we're going to answer them, and then later on we're going to publish these this material, make the online tests about it, so you can go and take the tests after you've participated or watched these videos. So now the first slide is about what we know as electrocoagulation, electrophotocoagulation, or is also called plasma, fibroblast. It's got many names, but it actually indicates the same phenomenon. That is to say, an electrical spark, which is all we're actually doing with this particular phenomenon here. So we've got an electrode that has a certain voltage, and the skin has 0 voltage or is ground. And because of the difference in voltage, if that voltage is high enough, then there is a spark. And this is what is referred to as electrophotocoagulation, plasma, fibroblast, electrocoagulation, and so on. So electrocoagulation is an application of electrical arcing or plasma or electrophotocoagulation. Fibroblast is another word for the same phenomenon. So everything refers to an electrical spark. Whereas lasers are something a bit different. They are light sources that have an impact onto the skin because of the light intensity, just the intensity of the light. As we'll see, the intensity of the light here is very little. It's actually doing nothing to the skin or anything. This is the classic laser tattoo removal blisters that people don't actually show, but this is the normal reaction that people get 2 to 3 days after a laser tattoo removal treatment. And this is to be expected and happens pretty much all the time. This is a hypopigmentation after laser tattoo removal, which can happen. Actually, it does happen most of the time. I've never personally seen any laser tattoo removal without any tattoo completely removed by lasers without leaving any mark or any scars. Now, all devices emit light of some form or another, like the display, the LED lights on the casing, etc. But that doesn't mean that they are light emitting device where the light is actually causing the skin change or is causing the skin burn or whatever we're trying to do into the skin. The infrared light produced by the higher temperature of the apparatus is always going to be there. So whenever there is something that is producing heat, we're going to have an infrared light. So again, even if you cannot see it, there's certain electromagnetic field emitted by the device. But that field, that electromagnetic radiation is not impacting onto the skin or even onto the human eyes. All devices emit electromagnetic radiation on one form or another. Not all radiation have any significant effects on the human body. This is the important part, because as we'll see, electrical arcing devices have no effects on the light emitted by electrical arcing devices like this one do not have any effect onto the human body or skin. So, as we said, all devices emit electromagnetic radiations, including all aesthetic devices. All of them do emit electromagnetic radiation. So they all emit light of one form or another. There are devices that emit electromagnetic radiation in order for the radiation to have some effect on the human body, and in particular the skin. And this is, as an example, the classic IPLs, lasers, the LED light treatment devices, and so on. Any device that uses the light in order to cause some change into the human body, into the skin, really. The main difference is that the electromagnetic radiation is causing some significant effect into the body in the case of this type of devices like YAG lasers, CO2 lasers, diode lasers, IPLs, and so on. Any light emitting devices which light has some effect onto the skin or the body in general. So what are the high intensity electromagnetic radiation emitting devices? So are any light emitting devices which light has some effect onto the skin or the body in general. So if you use, say, for example, an IPL, what you're going to find is that when you have the light onto the skin, then you'll feel the heat, and then according to the amount of intensity that you're exposing your skin, light intensity, you can feel the heat more and more up until pain, and then also you can change the duration of that light and so on. You can change many parameters of these devices. This category, then this intense light sources are required to be used only wearing protecting eyewear. Say, for example, if you've had a look at laser treatments, IPL treatments, you always find that both users, the user, the operator, and the person who's undergoing the treatment are both wearing some eyewear to protect themselves from that light source. This category does not include other devices which emit light which does not have any effect on the human body. As we will see and prove in this presentation is the case also of plasma devices. Plasma devices and their light emission. So now the points are that the light emitted by the arc is not causing any effect on the human body, and this is quite important because that's one of the main differences between light emitting devices, high intensity light radiation emitting devices, and arcing devices. As we will see, the light emitted by arcing devices is very little and has no impact whatsoever onto the skin and even the user's eyes or the person who's undergoing the treatment. So in fact, when you're seeing these devices being used, you do not find anyone wearing any light any eyewear in order to protect themselves from the light source. The light emitted by plasma devices or electrical arcing devices is merely a byproduct of the electrical spark. That's all it is. So whenever you have an electrical spark, say i.e. lightning and so on, you have some sort of just a second, some sort of just a second, okay, some sort of some sort of just a second, I've got a technical problem in here. Okay, some sort of light. So say for example, if you look at lightning, lightning is an electrical spark. The light produced by the lightning is neither dangerous to the eyes nor the human body. So as we know, whenever we watch lightning, we don't get blinded, we don't need to use any protective eyewear during a thunderstorm or anything, because the light produced by the spark, it doesn't do anything to the human body, let alone to the human eye. So there is no need for any protective eyewear by using electrocoagulation units or any electrical arcing devices. Electrocoagulation units or arcing has been used in electrocoagulation for several years, since the 1950s, 40s, and no one has used any eyewear protection in order to protect the eyesight against the light produced by these devices. Then the intensity of the light emitted by the arc is less to that of any normal displays that we have. Say for example, if we take the display of a TV, for instance, display of a computer, mobile phone and so on. So if you compare the amount of light that's been, the actual radiation that's been emitted by electrical arcing devices, you'll find there's a broadband radiation. However, the intensity is very, very, very small. Actually, the broadband is broader than any screen or any TV, but the intensity at any wavelength is extremely low. This is an example of electrical arcing or plasma or fibroblast, whatever you'd like to call it. And as you'll see, it's only a very tiny light that you get from the spark that goes between the tip of the device and the skin. And as you see, that is so small that you can still see it. However, the light from the light source, that is the sun at the moment, is indirect, is quite significant compared to that small one. This is another picture taken from one of our several treatments that we've got online. And then devices that emit electromagnetic radiations whose radiation causes skin change are, as we said, IPLs, lasers, LED light therapy. Mainly these three categories. There's no many others that we are aware of. But basically, when we are talking about electromagnetic radiation emitting devices or high intensity electromagnetic radiation emitting devices, we're always referring to these three categories. Those devices where you actually feel the light being emitted into your skin, and you do really need to wear a protective eyewear, and the customer as well needs to have some eye protection of some sort, depending on where the treatment is being carried out. Now, let's leave the title there, but the difference between IPL and lasers is just one of the pictures that we've got all throughout our website. Is that IPLs normally are a broadband spectrum light source, and lasers normally have 1, 2 to 3, sometimes even more wavelengths. If there's a multi-wavelengths lasers, but namely they're much more easily manufactured at one wavelength, or you can actually change the wavelength by filtering out that wavelength that you want. And that is an example of an Alexandrite laser, which has got a light at 755 nanometers, which is the wavelength, and a YAG laser at 532 nanometer. And as you'll see, the shorter the wavelength, the more superficial the effect onto the skin. The longer the wavelength, the deeper the penetration into the skin, which is completely different from the way electrical arcing devices work. They actually mainly have, the main effect is the ablation of the outer part of the skin, or that part of the skin is immediately impacted by the electrical arcing. So this is another very interesting picture here, because as you'll see, the green light, which is the same as the 532 nanometer one, is impacting the most superficial levels of the skin, whereas the longer wavelengths are getting deeper inside. And this is why, one of the reasons why IPLs have been used over the years, because you get a broadband light, and that broadband light is capable, because it's a very intense source of light, is capable of getting into the skin up to that bulb in there, so that it will eventually die away after a few treatments. Now, the light emitted by plasma devices. This applies to electrocoagulation or arcing units used in any other sector, including industrial and manufacturing. This is quite important, because what we're actually doing is that we're proving that electrical arcing devices across the board, not only in aesthetics, but also in manufacturing, because they're actually used extensively in manufacturing and for many applications. I'm not going to talk about them, but one of them is just to actually depolarizing the casings before painting them, because sometimes they're polarized, and because of that, it's impossible to actually paint them, and the paint is going to actually peel off if you don't actually depolarize the plastic casings. And it's got many other applications in textiles and many applications throughout the manufacturing industry. But I'm not going to talk about that. But the point is that in any application, there's no any requirement to have any eyewear protective devices in order to be near them. The main point is that electrical arcing devices do not emit a high intensity electromagnetic radiation which has any impact whatsoever onto the skin. And that is very, very important, let alone the eyes. So if the light emitted by this sort of devices were quite important and had some effect, certainly there would have been the requirement of having a protective eyewear, including manufacturing. No one across the board ever uses any eyewear. Protective eyewear against the radiation emitted by the electrical spark. As I've said before, and I want to repeat it, there's many thunderstorms, and no one ever thinks about, hang on a second, let me wear sunglasses because there's lightning outside. It's something inconceivable. Or you're just trying to light a cigarette. Some cigarette lighters use electrical arcing, and you need to wear protective eyewear. Or you have to ignite the fire in your kitchen using an electrical arcing device, because electrical arcing is also an igniter, a flame igniter, and you wouldn't even think about using protective eyewear for that application. So electromagnetic radiation protective eyewear is not used in the aesthetic sector. So you can go online and watch all these procedures if you wish. You will find no one wearing any eye protecting device in order to protect from the radiation itself. I myself have carried out several treatments, never had any problem. No one had any problem or concern about the light emitted by these arcing devices. No proof of any effect of any type by the light emitted by electrical spark or on any part of the body has ever been provided and can be provided, because it's very, very, one of the proofs is that, say for example, if you have a light emitting, an electrical arcing device, and you'll try the following experiment. As to say, you go and switch off the light and have this spark to ignite, and then you have a mobile phone screen. You'll probably find the mobile phone screen is going to emit much more light than the spark itself. This is just one example that you can actually carry out yourself. The only effect is the visual lightning stimulation caused by the electrical arcing. So basically, the main confusion is because people are not very well hooked on to the physics of electrical arcing. Not everybody's a physicist. So if you look at electrical arcing devices, you say, oh, it's a laser. It's not a laser, because as we will see, what's causing the heating effect onto the skin, or the ablation effect onto the skin, is the electrical spark or the electrical current that is carried by the spark. That is what causes it. In plasma devices, it's the heat caused by the electrical spark that causes the heat into the skin, not the light itself. The light emitted by the spark is a broadband spectrum electromagnetic energy which has negligible effect onto the skin and the human body. And that's a fact. How is this proven? We already talked about it. There's many proofs of that. One of the several, just you've been in a thunderstorm before. So, and then you can carry out these experiments on and on. Nothing will ever happen to your eyes due to the light emitted by the spark. In the operation rooms, one of the proofs is that if you, this, as I said before, has been used in the operating theatre for several years, since the 40s, 50s. And no one has ever used any eyewear protection in using electrocoagulation units. It's just a fact. So this is a laser protective eyewear which is not needed, or IPL is not needed. You've never seen it in the use of electrical arcing devices, and you will not see it. This is an intraocular eyewear which is actually needed for laser treatments if you're doing a laser treatment around the eyes, but not so even CO2 lasers. That sometimes is used with CO2 lasers as well. But no electrical arcing device. If you've actually watched so many treatments, electrical arcing treatments onto the upper eyelid area and lower eyelid area, no one has ever worn this type of protective intraocular eyewear to protect the eyes, and these are also quite uncomfortable. Look at the swelling of the eyes. It's not comfortable. Differences and effects. Those devices in which the light, the electromagnetic radiation per se, has effects onto the skin as color sensitive in tattoo removal. We have a tattoo removal slide which we're going to go into quite shortly. And then we're going to look at that, but we have some pictures as well. The skin type of the subject has to be taken into consideration before treatment. So what we mean here is that whenever we are dealing with lasers, IPLs, and so on, LED light treatments, the skin tone is very, very important. So you cannot treat a skin type 5, 4, or 6 in the same intensity that you're using a skin type 1 or 2 or 3, because the presence of melanin will have the same intensity to be absorbed far more by the darker skin types. This is why sometimes people prefer not to treat darker skin types with lasers or light emitting devices. Those devices which emit electromagnetic radiation, but the light emitted has no effect onto the human body whatsoever, are color blind, can remove tattoos of any color, and can be used on any skin type, and that's it. So you don't, well, what we're saying here is that If you're using electrical arcing devices or the parent of electrical arcing devices are radio frequency devices, you can use them on any skin type, and you don't change the setting of the unit based on the skin type that you are treating. So you can use this, you can use setting 1, for example, for skin type 1 till 6. If it's good for skin type 1, it will be good for skin type 6. Whereas it's not the same with the lasers, IPLs, etc. So you always have to lower the intensity. The intensity is sometimes, say for example, in IPL, not only you have the light intensity, but you have the pulse duration as well. So you have to both lower the pulse duration and the intensity for darker skin tones, whereas you have to increase it for lighter skin tones. And again, is due to the difference in melanin in the darker skin tones, because the darker skin tones have got a lot more melanin, therefore they absorb much more energy than the lighter ones. And also in tattoo removal, as we will see in the slideshows, in tattoo removal treatments using lasers are color sensitive, whereas if you use plasma treatments, there's no color sensitivity whatsoever. And this is a very, very, very important point. So you can actually attenuate all colors across the whole spectrum, which is quite an important point. Then this is, in this slideshow, all we're doing is that we're just showing you an example of where the wavelengths of certain laser are effective on certain colors. Say for example, this wavelength is effective somewhat up to say almost red, yellow. Then you would use this wavelength, 1064 nanometers, in order to remove blue and darker colors. Then the 964 has been shown to be somewhat effective, somewhat again, on greens, but green colors in tattoo removal are quite difficult anyway. So that is exactly there. So if you've had a look and studied lasers, then you'll in the literature is pointed out, light and green color tattoos are a nightmare to attenuate. And this is another example. So this is, say, normally you can actually attenuate darker colors quite more easily than the lighter ones and the green ones. And this particularly, we're actually going with that wavelength in order to try and attenuate the green ones. Again, this is just an example. In reality, it doesn't work that way. Really, tattoos are never removed, I would say almost never removed completely without leaving any trace by lasers, and as a matter of fact, unfortunately. Then we're going to go more deeply into that in the tattoo removal section. This is another example where we're seeing that the darker colors after laser treatments are more attenuated than the lighter ones. And this is just another example where we show the type of wavelengths being more effective on certain colors than others. So what are arcing devices? How are they designed? It is the heat, again, this is a very important point. We're going again and again, so it sinks in. It is the heat caused by the electrical discharge which causes the thermal effect onto the skin. It is not the light generated by the spark. That is a very, very important point. The electrocoagulation or electrophotocoagulation units are a subtype of radio frequency devices. The main difference is not the frequency between electrophotocoagulation or plasma devices and radio frequency devices. There are two parameters: the operating voltage, because in the electrical arcing devices you've got a higher voltage, and the shape of the electrode. Normally the shape of the electrode, as you'll see, are pointy, so that to take advantage of the phenomenon, a very well-known phenomenon in physics, which is called the tip effect, which helps produce the spark. And normally the frequency of these devices ranges between 50 kilohertz up to a few megahertz. So the light, again, the light emitted by arcing devices or plasma devices or fibroblasts, whatever you like to call it, electrocoagulation, electrofulguration units, has no effect onto the skin, have no effect on the eyesight, there's no need for any protective eyewear, has no effect of any organ of the body, including the eyes. You've seen plenty of treatments on the upper eyelids and the eye area. This is another comparison picture. Look, in here we've got loads of light. In this picture we've got loads of light, all of which is actually illuminated by the indirect sunlight. So the sunlight is actually illuminating the room indirectly. And look at how small that light source is. So if you actually switch off, if we have a completely dark room and or it's night and we don't switch any light on, that very little thing will not be able to be cannot be compared to the light emitted by a mobile phone screen, which is far brighter and can illuminate much more than that tiny little bit. So upper eyelid tightening, so electrical arcing devices and aesthetics. Upper eyelid tightening, there is no need for intraocular protection. So you've seen many of these treatments. There's no any intraocular protection, and you're not going to find any because there's no need for it. Because the light does not have any effect onto the human body, and therefore it poses no danger to the eye, which is a delicate organ, we will all agree. And there's been, with several devices, Plex, or whatever you want to call them, thousands and thousands and thousands and thousands and thousands of these type of treatments being carried out the world over, never damage to the eyes. Whereas this protective eyewear is necessary using lasers, IPLs, etc. There's no frosting effect onto the skin, as we've seen in the previous slide. So whenever you're using a Q-switch laser, you normally have skin frosting. Depends on how you use it, because sometimes it's the effect is so deep that you go and get some bleeding immediately without any frosting. The plasma devices are very compact, pen-like sometimes, and this is only possible because their design is much simpler than intense, high than IPLs, lasers, and so on. Any high intensity electromagnetic producing device. And this is just the frosting which I've actually talked about, caused by lasers, and you can see the redness there. And this is quite a normal phenomenon. So how is the heat propagated into the skin using electrical arcing devices? Now, if you looked at the physics of electrical arcing devices, which we've got online, that explains it, but it's the same principle as radio frequency devices. Is actually the electrical arc, which ionized gas work in a similar fashion as a superconductor. So what happens here is that electrical discharge that causes the burn. It's like when you look at a lightning striking a tree, you'll find that a part of the tree is being burnt, but it hasn't been burnt by the light, it's been burnt by the electrical discharge. So it's a very different thing. So you can actually be quite close to the tree, the light hits the tree, it burns the tree. It's not the light, the lightning burns the tree, but it's the electrical discharge that does the burning. It's not the light itself. It's only a visual effect, and the light does not cause any danger to the human eye or any part of the body. So as the heat produced by the microcurrent of the electrical arc that causes the effect onto the skin. In other words, it's the electricity that propagates the heat, not the light. The light emitted by the arc is only a byproduct of the type of technology or the type of physics that we're using these devices. So this is just a laser tattoo removal slide where you see the light being fired into the skin. The tattoos are normal into the dermis. The part of the skin gets shattered, and then you get the partial absorption and so on. Again, a light source, which it works in a very different fashion from the electrical arcing devices. A Q-switch laser causing bleeding during the treatment, which is something that can happen, and it's nothing to be worried about. It's just something that happens every now and then. So the treatment can cause bleeding immediately. And this is the effect of tattoo removal, laser tattoo removal, which causes the swelling after 1 day, 24 hours, or 2 days, which goes away. And almost normally for any light emitting devices that use high intensity light, then the skin type is very, very important. So you've got to change the setting of the device according to the skin type. And this is something that doesn't apply to the arcing devices. This is a tattoo removal using arcing, but this picture has been taken 10 days or so after the treatment, but that actually goes back to normal, and there's no scar left after that. The after picture is on our website. So it's now question time.
Okay. First thing I wanted to say that I find that these arcs, I guess basically what I'm gathering is they're all pretty much the same. What I'm also gathering is that numbing cream does not work for me. Because I still feel it very much. So that's one thing. The other thing I wanted to ask you, I just wanted to comment on that, and if you know of a better way of dealing with this pain during the actual sparks on the skin, I would greatly appreciate anything on how to reduce that pain, because the numbing cream doesn't seem to be, I may not be a good candidate for numbing cream. And the second thing I wanted to ask was, request, maybe you have this on your website, do you have just briefly just take me through the steps of how to prepare the skin, and then afterwards what to do with the skin for the client or whoever's getting it done, or if I'm doing it on myself, what do I need to do to make sure that I'm doing the correct thing without avoiding any hyperpigmentations or any scarring?
Okay, now what type of numbing cream have you used so far?
What type of what?
Numbing cream have you used?
I have tried lidocaine, 5%. I've tried 10%, and I recently tried 14%.
Yes, okay. Now there is the exact formulation is on our website onto how to numb the area. Let's see whether I can actually go there. Medical numbing products. Look at this one. Look at this form. Can you see the formulation there?
I do, yeah.
Good. So okay. you know where to find it. So the legislation changes from country. So just we don't need to take a note. It's there. It's on this page here. And then I'll just do it again.
Okay.
You just basically these are the topics there, and then you go use of numbing products and medical numbing products. If you use a medical numbing product, we're calling medical because it depends on the legislation you've got locally. In Europe, this can be used by prescribed by doctors, and this is a type of numbing product which is actually numbs. You cannot actually feel. I'm gonna stop the screen sharing just a sec. Can you see me again? Yes. So look. Can you see me again?
You mean the screen?
Yes.
I was able to see that, yeah.
You can see me again. So I've actually used it myself. I've had the treatment done myself, and you can go with a 5% lidocaine, but you have to use occlusion. We talk about occlusion on our website. Exactly. I think we talk about it somewhere else on our website. So if you use 5% lidocaine, which you can find quite easily online, then you need to use occlusion for 45 minutes or even an hour. Is a bit of a pain in the neck to wait for that long. And even then, sometimes it's not that numb. But if you use a very good numbing product, which has got a high percentage of lidocaine, or that sort of formulation that I showed you just now, and then even then, it's very rare that it doesn't work. It's very rare. But if even then it doesn't work, just try to use an occlusion and numbs everything. Basically, you don't feel the pain.
What?
Occlusion. Do you know what occlusion is? If you don't know what I mean by occlusion, I'll just show you again. Just a second. Oh, beautiful. There you have it. This is occlusion.
Yeah,
Can you see that?
Gotcha.
So this is what you must use if you're using this sort of 5% lidocaine. If you just keep them there, you're not going to do anything. You must occlude them. That's called occlusion.
I actually used that. I mean, I did seal it. Perhaps I need to use more cream, more numbing cream.
No,
when I used it,
I mean,
I did use it. I used a piece of plastic and sealed it.
No. Plastic is not good. You either want to use something of the sort, a fit for purpose product, or what do you call it? Cling film. But yet, I mean, look at this. This is what you normally find. This is a good practice as well. But what we normally use, because very often we've got doctors there, we use this formulation. So you put it on 5 to 10 minutes without any occlusion. The part is dead, cannot feel anything. Even I couldn't feel anything.
Long?
5 to 10 minutes.
Okay.
5 to 10.
Wow. Okay.
And it's a very this problem that you're complaining about is very easily resolved.
Just go to the doctor and get a prescription. Okay.
If you're a doctor, it depends on your legislation. I don't know where you're calling from, but it depends on your legislation, really. In Europe, you do need to be a doctor in order to prescribe this product and use it. Or someone can use it under doctor's supervision. But it depends on, it's also very local. I mean, the enforcement bodies change the way they look at it based on what country you are in Europe. So it really it depends. So did I answer your question?
The first one, yes. Thank you.
Okay, what was the second one? I'm getting too old.
Can you briefly just take me through from start to finish, just like the steps of how you prep the skin? Then, of course, you do the numbing, but is there any disinfecting that you want to do on the skin? And you mentioned it on the needle as well. You mentioned that little machine that sort of sterilizes it. In the event that one doesn't have that just quite yet, is there an alternative step I can use instead?
Okay, let's go again on to where we aftercare, general downtime, pre-treatment. Let's have a look.
Okay.
Everything is there. Yes, you've got. Okay, before applying the product is there. You'll find it in writing, but I'll try to. Basically, you have to do the cleansing. You don't need to do much of sterilizing the skin. The skin will never be sterile. Just do a normal cleansing. If you have benzalkonium chloride, you can use some benzalkonium chloride based antiseptic after you've finished with the cleansing. But it's a normal cleansing. The skin will never be completely bacteria free, but you just want to perform a normal cleansing, and then you apply your numbing product, and then you take off that numbing product little by little, and you apply the spots little by little up until you finish the job. It's not rocket science. In terms of the type of the device, if you're using our product, our device, then if we didn't so you know where to find this actually. Is aftercare pre-treatment. You find this in the pre-treatment. So it's actually detailed somehow step by step, but it's not much to it anyway. It's in the pre-treatment. And I'm going to stop the screen sharing, and I'm going to go back into the Hangouts. And then about the needle, depending on what device you're using, if the needles are sterile or not. If you're using a non-sterile needle, then you have to use an autoclave to sterilize it. If you don't know what autoclaves are, I'm going to go again. So look, I'm going to go to screen sharing again. You can go into, okay, just a second. I'm going to go into screen share. And also you can Google autoclave, screen share.
That site is like an encyclopedia. It's fabulous.
Well, our websites.
Yeah.
Thank you. I think it's a compliment. Then you go there, and then you go on to beauty tech. Now, I just know where things are on our websites because I've actually made them myself. So, and it took a while. Now we've got other people working on it, which makes it much easier. Starting this business has been quite demanding. Just a second. So it's going to go into the frequently asked questions very quickly. And what you have, if you go, what can I use to sterilize the electrodes? Autoclave, and you can buy them quite cheaply online. Autoclave, and normally it's something that dentists use. Also in many countries in Europe have been used by barbers and so on to sterilize their razors and so on. So it's an autoclave. It's something is quite well looked at in Europe in general. If you have an autoclave in your facility and you show that you're using it, any authority will be more than happy that you're complying with health and safety. But you do have to use it.
Okay.
If the needles are not sterile. Oh, there's another point. There's another point.
The needle.
There's another point. There's another point I'd like to make. The needles must be sterile. However, it's not as if you're actually shaving, because the tip of the device is not meant to be in contact with the skin, and also the temperatures caused by the electrical arcing are very high. So even cross-contamination if you use the device properly, is very unlikely. However, you're still dealing with the skin. There's always some likelihood of getting some skin pierced and so on. Certainly it's not like a tattoo. You're not actually getting into the skin willfully. It's not like tattooing. So, but still, we do say in our manuals that they've got to be sterile, and this is one of the ways that if they're not sterile, you can sterilize them. Did I answer your question?
Well, the needles that I'm using have plastic at the upper part. I'm not sure if I could use that autoclave with those. Would I be able to use it if there's plastic on the? I can do that?
I'm not sure. Again, it's a manufacturer's question. You want to ask your manufacturer.
Okay. Thanks so much for answering those questions.
It's a pleasure. Any other questions, even not related to this slideshow?
I have a quick question. I'm not sure if you covered it yet because I just joined in. Did we cover what the energy, or the measurements of energy that we would be using for plasma therapy?
Okay. Can you just ask the question again?
Sure. Each device has its own option for energy levels.
Yes.
During treatment.
Yes.
Know what those energy levels are for fibroblast or plasma therapy?
Okay. This is a bit of an intricate question. I think we're going to make a slideshow on that. It's been covered on our online training platform and also in some videos. Now, we define intensity of the treatment in skin tightening. Something that you've got to relate with the duration of the arc,
Right.
the power intensity of that arc, so the power setting of the device, whatever device you're using, the distance between the spots. So there's three main parameters, and a fourth one, which is not that important, but it's got a certain amount of importance. The how wide of an area that you're actually treating, but that's not that important. But the main important points are three: intensity of the arc, how long you keep the arc for, and the distance between the spots. This is in skin tightening. There is a video's got loads of hits on our channel, which is actually sort of covering this. But I think we're gonna make a presentation on that in particular. Do you understand why I'm saying that?
No.
No. You don't understand why I'm saying that.
Maybe frequency can't be measured or intensity.
Okay, let's see whether I think we've got to make an ad hoc presentation. But what I'll do right now, I'll see whether I can actually find this video. It's going to be on YouTube. Where is it?
It's like some machines will have 3 settings: high, low,
yes,
medium. Others will be have finer tuning.
Mm-hmm.
How do we know what's best for the skin tightening?
Well, okay, I'll send right now in this chat the a video that's got it's quite useful for that, because we've covered this in range in other presentations before, but I want to make another one to make sure that we're going to cover it even better. So I'll send you that for you to watch later on. That hopefully is going to clear up what I've just said there. See whether I can find it easily enough. You have to actually go to your manufacturer and say, look, how am I supposed to use this? we actually, sorry to actually say that. I don't mean to be mean or anything. We'll try to help as much as possible. And we're actually trying to cover this topic in an ad hoc presentation. So look, plasma in principle and applications in aesthetics. Yes, watch this particular, if you haven't watched this, watch this, and that is going to give you some background on what I've just said over there, but we'll try and cover that. Where am I? The point is, I'm not sure how whatever device you have has been designed, what power level it has. There's so many out there. The scope is so wide, which I'm not able to do. I'm able to do it with ours, and actually send you the link with ours, because we have had this question with our device, and I'll send you the link with our device, because we had a similar question with our device, and I'll show you what we've done with our device. Just a second before we sorry to keep you. I want to send this thing out so you can actually see it, have a look at it later on, because it's quite a good.
Perhaps it's the end point that we would be looking at, like if we're looking at a dot that's still bright red or reddish brown or dark brown, like already scabbed over. that might be a good indication if we're using it too high or too low. Does that make sense?
Just a second. Really, we recommend for, so look, I just want to go into, Beauty Tech protocols, there you are. This is going to be of great help. Your manufacturer should actually produce something of the sort, so look, or should give you something of the sort. With have a look at this, because it actually gives you the power settings and roughly how you've got to use the power settings and so on for each application. And it does it in a, and it does it, but this is with our device, with our settings, with our frequency, everything. And then I'll make a presentation in this topic on the next course, on the next month, because it's a very interesting point. What I would say is apply the spots operation using a low intensity treatment to start with, if you're not sure, and then you see the results and you increase the intensity as you go along. And the intensity is determined by 3 factors, as I say. One is the power level. One is how long you keep the power, the arc for, and the last one is what the distance is between each point. So if the shorter the distance, the higher the intensity. The longer you keep the arc on for, the higher the intensity, and the higher the power level of the arc, the higher the intensity. But I'll make another presentation on that, and we're going to cover it a number of times, because I understand this is something that is of great interest, and it's not covered well, and we haven't covered it well.
Okay, very good. Thank you.
But we'll try again. We'll try again, not only next month, but when we're going to go out again, we're going to make presentations on this topic a number of times. So we're going to cover it from a number of angles. So then you can watch a number of videos, and hopefully you're going to get that concept quite strong in your mind by having a number of videos that you can watch.
Can you hear me?
Yes.
Oh, hi. Can you tell me, is there a difference between the term electric arc and plasma arc?
It's the same thing. Okay. It's the same thing.
There's a lot of controversy in the market.
Okay. Can you please tell me what is the controversy in the market?
So I'm from Australia, and there are some people saying that certain machines have an electric arc and they're not plasma, so they cause too much damage to the skin, but I don't know how to tell the difference.
Yes, what they're doing basically...
And some of it I think is propaganda, so I just wanted to find out.
Yes, pretty much it is, yes, pretty much it is. I mean, in the last... it was on Sunday, somebody said that the Plexer and the Accor were the only ones using nitrogen. We're the only, and then we looked at that. It's true. It's actually not true. Well, it's true that they're using nitrogen, but it's not the only ones, because every Arkin device is using nitrogen, because the atmosphere is made by 78% of nitrogen. So basically, there's many tricks that people are using in order to try. It's a very competitive market. You find lots of things out there, and people are trying to confuse the market, to confuse the customers. Because obviously, if let's let's sit in my shoes. I'm a sales guy, and I'm selling you something for, I don't know, $6,000. I'm only saying, and I'm investing money into an exhibition. I'm investing money into come into your practice and do the treatment and so on. And then you're saying, very interesting, I like this. But everyone says the same thing. Well, I just want to look around. So they're trying to close you off to potential alternatives. I'm trying to say that anything else is unsafe Anything else is unsafe. It's not the same thing. And then you scratch your head. Is it not? And then obviously not having a physics background, I'm an electrical engineer, I've designed these things. I bought the very expensive ones that have been sold for a lot of money. And when I actually tried them and I've actually examined them, I thought, oh, what the heck? this is, I wouldn't say it's a scam, but I mean, I've been overcharged. Not by far. I've been overcharged. So that is basically, hopefully I've answered your question. You got it right. It's completely a marketing exercise to try and close you off to potential alternatives that are more are cheaper. Basically, let's assume someone has invested the money to on an exhibition and so on, and you see that device and it's, hang on a second, this is expensive. Let me look online, and then all of a sudden you find online something that is a fraction of the price. And you're like, what the heck? And then you call back, well, they're trying to sell you it. Well, by the way, I've seen it for such and such price. Why are you selling it for 10 times as much or whatever? How much as much? So then, obviously, they're trying to find ways in order to close that off. It's a very competitive market. This is the reality.
That's really good information.
Yeah, and you get it from us. One of the reasons why you get it from us, although we have interest in selling it, is that we have got a very different approach to other people. We're investing heavily on two things, into devices, which we're actually designing another one, but into training online. Something that people don't dare do because it's got a long, I mean, whatever we do today, then it's going to have some effect maybe in 1 year, 2 years and so on. No, they want to get a quick result, a quick sale, so they don't do it. So basically we have a brand name, so people keep buying things from us anyway, and this is helping our brand in the future anyway. So, and one of the things we are recognized for is telling the truth, even if it's painful.
Thank you.
Very welcome.